So hello and welcome to this demo session. I'm Siddhant Ranade.
Hi, I'm Meghas Sham. In this demo session, we'll be talking a bit about image processing. So an image is basically a set of pixels. So it's basically a matrix in which you have some numbers inside. So when I talk about a black and white image, a black and white image has color as white, black, and shades in between of black. So white is 255, black is 0, and any other number in between 0 and 255, it's a shade of gray. So when we look at a black and white image, it's a set of pixels, and so it's a matrix in which the numbers are from 0 to 255.
And if it's a color image that we are talking about, then instead of there being a single matrix, you have three channels. So basically, it's a three-dimensional matrix where each channel stores values from 0 to 255, and you have three such channels, and each channel represents one of the three colors: red, green, and blue. So there are various ways of storing this, but RGB is one of the standard ways. So each of these channels, as we call them, stores one of the layers, and each channel has a grayscale image in it.
So if you have used Instagram or any other photo editing software, you'd have seen filters like blur, motion blur, or sharpen image. So these are results of convolving the image which we have with the convolution matrix. So this is a practical use of convolution. So we'll talk about how this convolution matrix goes. So let's say we have a small image, a 4x4 image. It looks something like this. So this image is basically whites in between and surrounded by dark pixels and with a little gray here. And let's say we have a convolution matrix which looks like this, a 3x3 convolution matrix. Okay, now let's say we have a convolution matrix which looks like this. Now how do we go about applying this matrix on this? So let's apply this matrix on, say, this pixel over here. So we center the center of the matrix on this pixel. So let's do that. I'm just taking out 3x3 boundary across that pixel, and I'm placing this matrix atop of this. So, and what we do is we multiply the corresponding elements, and add all of them together. So what we eventually get is, since these are all zeros, only this will contribute. So we'll get 255 out of here. Now this is the same value, but if you look at this pixel over here, so if we apply this matrix on this pixel, we'll get 0. I mean, this is the one which will be filtered out. So this matrix basically results in the picture or the matrix shifting a point to the left, a pixel to the left. We'll show the the graphical representation of this shortly in a demo. And let's say you also have, how do we introduce blur in the picture? You know what a blur is? Something like you have your camera and then you have shaky hands. So you take an image, you see that the image is a bit blurred, it's not sharp. So how do you give an example of how this blur occurs? Let's just take a look at it. Let us take a slightly different image from last time. So we have except the image is same except for this particular pixel over here, which is 250, and let's apply this convolution matrix on this pixel over here. So we'll multiply the corresponding elements, this, and so the sum would be, the rest are all zeros, so only these two get picked up, which is 255 plus 255, which is 510. But this is out of bounds. Our pixel values are supposed to be from 0 to 255 only. So why is this happening? It's happening because we haven't normalized this convolution matrix. So normalizing is basically, take the sum of all these values in between and just 1 upon sum. Here the sum is 1 plus 0, 0, 0 and 1, so it's 2. So when you normalize this, the resultant value will also be into half, which is 255, which is in bounds. So yeah, that's basically a convolution matrix and normalization. Now what this matrix does is it introduces a blur. We'll see more of this in the demo, which will happen shortly.
So you might ask why this is a blur. So it is a blur because if you look at it carefully, it is just two shifting matrices. So if you only had that one in the top left corner and zero everywhere else, so it in effect you would be shifting your image to the right and downwards. And if you only had a one in the bottom right corner, you would be shifting your image upwards and to the left. And if you take these two images and you superimpose them, so you take these two images and you sort of take the average of the two values at each corresponding pixels. So in effect you are mixing pixels. So if you mix pixels, it is a blur. So that's basically how you get a blur.
So we'll see a demo of this thing happening now. So now here we have our standard, the chessboard. Let's apply the blur which we were talking about. So this is the blur. Now, okay, I apply the blur a few times because the image is a huge image and the just mixing two nearby pixels over here. So let's just compare the blurred image. See the blurred image with the original image. You can see that the edges are a bit away from what they're supposed to be. And let's just talk about the shift also, which I just said. This shifts the image by just 1 pixel. As you can see, I'm just keep on applying the shift filters. You can see that the image is moving towards the left. So that's the shift. And there are a lot of convolution things also. This is basically the identity filter. It does nothing because it just takes the pixel at which the convolution matrix is centered. And this is a Gaussian blur, which basically blurs the image as such, another different way. So you can see the difference between both of them. Let's load the standard test image, which one of the standard test images. It's called Lena, and this convolution matrix over here, it sharpens the image, which is like you can see what it does exactly. So I'll just compare both of them. So you can now clearly see that the sharpened edges are highlighted as such here. It's the image is a bit more sharp. So that's what when you use the camera photo editing software and as such, this is a edge detection filter. It does what it exactly says. It detects the edges in the image. So you can see the hat, the hair here, the hat, the hair. You can see the eyes also, the elbow, and this was a demo which we did in MATLAB. You also can use many open source photo editing softwares. We'll just take an example of one of those. It's called GIMP. So we have the koala image here. So people, you can download GIMP. It's for free. Download GIMP, load your test image, whatever you want. Then go to filters, and then go to generic, and then you'll have the convolution matrix there. So yeah, you can play around with this. It's a 5x5 convolution matrix. I just want to show the blur image here. Now you can see I'm not normalizing this thing here. Okay, so it just has 1 and 1. I'm not normalizing this thing. So you can see what happens if I don't normalize it. So the pixels get added and they are walled off at 255. So you see it's losing most of the information in the image. So let's go back to the filters. The same thing, except I'll normalize the filter this time. But the image is already bad. Let's just go back to the image. This is the original image, and then yeah, this time I'll normalize the filter. Convolution matrix will have the same thing, except I'm normalizing it this time. So I'll just put an OK. So you can see the image has shifted a bit downwards and has a blur because it's the identity and the shifted image added together. So yeah, people, you can play around with this in GIMP. So yes, people, you can play around in GIMP, make your own software in Scilab, MATLAB. Yeah, you can play around, and I'd like to see more of this discussion happening on the discussion forums. Thank you very much.
Yeah, thank you.